numbers on both sides of an equation and multiply and divide numbers to both sides of an equation. In this lesson, you will learn how to solve more complex linear equations. In order to do this, you will need the knowledge that you have gleaned from the previous two lessons. We are going to be focusing on solving equations when the unknown variable is on both sides of the equation. Here are some examples of the equations that we are going to try to solve. 4 times x plus 2 equals 5 times x minus 3, minus 5z equals 3 times z plus 1, or 6 minus 2 times n minus 3 equals 3 times 2n plus 4. In all three of these examples, you will notice that on both sides of the equations we have the unknown variable, and you will notice that we have brackets. So again, you may want to look at the lessons on the distributive law. When solving equations, there is a very important rule to remember, and that is you need to balance the equation. So, what you do to the one side, you must do to the other side. Solve for x in 4 times x plus 2 equals 5 times x minus 3. First, we need to enforce the distributive law. We multiply the 4 into the brackets, and we multiply the 5 into the brackets. And so we get 4x plus 8 equals 5x minus 15. The next step is to bring all the variables to one side of the equation and all the constants to the other side of the equation. So first, let's take the numbers with the x in them to one side. We then get 8 equals 5x minus 4x minus 15. This then gives us 8 is equal to x minus 15, because 5x minus 4x gives us x. Now we need to take that minus 15 to the other side of the equation. And so we get 8 plus 15 equals x. And so we've solved our equation. X equals 8 plus 15, which means x equals 23. Solve for z in minus 5z equals 3 times z plus 1. Again, we need to use the distributive law and multiply the 3 into the brackets. So we get minus 5z equals 3z plus 3. Now we need to isolate z, and so we take all the z's to one side. So we get minus 5z minus 3z equals 3. This then gives us minus 8z equals 3, because minus 5z minus 3z equals minus 8z. Now we isolate z by dividing both sides of the equation by minus 8. And so we get z equals minus 3 over 8. Don't forget to watch the signs. A plus divided by a minus gives us a minus. Solve for n in 6 minus 2 times n minus 3 equals 3 times 2n plus 4. So again, we distribute the minus 2 into the brackets and the 3 into the brackets. This gives us 6 minus 2n plus 6 equals 6n plus 12. Please watch the signs when you distribute. Now we are going to take the variables to one side of the equation. And so we get 6 plus 6 equals 6n plus 2n plus 12. Now we take the constants to the other side of the equation. And so we get 6 plus 6 minus 12 equals 8n. Where does the 8n come from? Well, remember, 6n plus 2n is 8n. And so, our equation is now 0 equals 8n. We now divide both sides of the equation by 8 to isolate n. And so, 0 over 8 equals n. And finally, this means that n equals 0. In this lesson, you will be introduced to the definition of alternate angles, the different types of alternate angles, and we are going to apply the theory of alternate angles to solve problems. We are now going to begin by looking at alternate angles. You may ask yourself, what are alternate angles? Alternate angles are formed when a transversal runs through a pair of parallel lines. The alternate angles are the pairs of equal angles on opposite sides of the transversal. So, if we look at the diagram, the following are alternate angles. In this diagram, the dots indicate a pair of angles. These angles are alternate angles. These two angles are equal in magnitude. We say that these angles are alternate angles as they lie on opposite sides of the transversal XY. In other words, they alternate. Often, alternate angles are associated with a Z shape. So, if the parallel lines and the transversal form a Z shape, we may need to consider alternate angles. Let's look at another example of alternate angles. Once again, these two angles are alternate angles. They still can be associated with the Z shape that was mentioned earlier. However, you will notice that they are different from the alternate angles in the previous diagram. Alternate angles may also be associated with a sigmoid or an S shape. In this diagram, the two angles indicated by the triangles are alternate angles. This time, their positions create somewhat of an S shape. Because of the fact that these two angles are alternate angles, they are equal in size. The last pair of alternate angles that we get are the ones you see in the diagram. This pair of alternate angles is denoted by the circle. Once again, these angles create a bit of an S shape. Now, there are two types of alternate angles. These are the interior alternate angles and the exterior alternate angles. Let's look at interior alternate angles. Interior alternate angles are alternate angles within the pair of parallel lines. So, the interior alternate angles would be and. In both cases, you will notice that these alternate angles are inside the parallel lines. This is the feature that makes these angles interior alternate angles. Let's now look at exterior alternate angles. Exterior alternate angles are alternate angles that lie outside of the parallel lines. The exterior alternate angles would be and. Once again, in both cases, it is clearly evident that the alternate angles lie outside of the parallel lines. It is these parallel lines that together with the transversal create the alternate angles. Before we begin solving problems involving alternate angles, remember that alternate angles are formed when a transversal passes through lines that are parallel. Alternate angles are associated with either a Z shape or an S shape. So let's jump into a few examples. The first example says that we must calculate the magnitude of the angle that is labeled Y. So, you will be able to make the following statement. Y is equal to 61 degrees. Now, the reason for this is we have interior alternate angles, and these interior alternate angles are created by the fact that the line segment PQ is parallel to the line segment XY. Please note, when attempting geometry problems, the format of your solution must always be two columns. There must be a statement column and a reason column. This is because in geometry, all statements must be corroborated or justified. In fact, this is the case in any science. There is also a second thing I would like to point out to you. A bar is placed above PQ and XY. This indicates that these lines, in the loose sense, are line segments rather. That is, the line segments have a finite or limited length that is constrained by the two endpoints that are labeled on the line segment. So, if you look at PQ with the bar on top of it, all that means is that PQ is a line of limited length where the endpoints are P and Q. We are now going to look at the second example. From the diagram, we have been asked to determine the value of x. So, firstly, you will notice that the angle that is labeled F has a magnitude of 100 degrees. Now, what is the reason for this? Well, we know that the lines AB and CD are parallel. Also, there is a transversal that runs through them. So, we need to consider alternate angles. Now, the reason that F is equal to 100 degrees is because we have exterior alternate angles, and this is created or induced by the fact that the line AB is parallel to the line CD, as I had mentioned earlier. Now, we also know that the angle that is labeled E has a magnitude of 80 degrees. Now, what is the reason for this? Well, we had established that angle F is equal to 100 degrees. We also know that angles E and F, when added, create a straight line which has a total angle of 180 degrees. So, if F has a magnitude of 100 degrees, then E must have a magnitude of 80 degrees. Finally, by knowing what E is, we can easily determine the magnitude of X. We know that angle E and angle X are equal, and the reason for this is that they are interior alternate angles. And this is because the line CD is parallel to the line EF. Therefore, because angle X is equal to angle E, and angle E is equal to 80 degrees, we can conclude that angle X has a magnitude of 80 degrees. I'd like to point out something to you. Whenever parallel lines AB, CD, or EF are referred to, you will notice that a two-way arrow is placed above the letters. This indicates that we are dealing with lines that are infinitely long and carry on in either direction. The fact that we have used the points AB and then we have put a double-edged arrow on top simply indicates that the points A and B are points on the line, but they are not end points of the line. We are now going to move on to the third and final example. By considering the diagram, we have been asked to calculate the values of the unknown variables. In other words, we have been asked to calculate the values of L, K, and M. So, firstly, you will notice that angle L has to have a magnitude of 50 degrees. The reason it has a magnitude of 50 degrees is because we have vertically opposite angles at the point B. Now, you will also notice that the lines AB and CD are parallel. Therefore, angle L has to be equal to angle K. You should notice that we have an almost Z shape that is formed. This indicates that we have interior alternate angles. Now, because angle L is equal to 50 degrees, and we know that angle L is equal to angle K, this implies that angle K has a magnitude of 50 degrees. Finally, all that we have to do is determine the magnitude of angle M. Now, if you look at angle M and then you look at the 45-degree angle, you should notice that we have almost a Z shape that is formed there. Also, you can see that the lines CD and EF are parallel, and that line segment ED acts as a transversal. So, you should already be thinking of alternate angles. We can therefore conclude that angle M is equal to 45 degrees because we have interior alternate angles, which has been caused by the parallelism of line CD and line EF. In this lesson, you will be introduced to the definition of co-interior angles, and you will be shown how to identify co-interior angles. When a transversal passes through a pair of parallel lines, a variety of angles will be formed. A pair of such angles is consecutive interior angles. These are commonly referred to as co-interior angles. When a transversal passes through two parallel lines, co-interior angles will be formed. Co-interior angles are the pair of angles on one side of the transversal inside of the two parallel lines. Let's look at diagram 1. Angle alpha and angle beta are co-interior angles. You should notice that the line AB is parallel to the line CD. And there is a transversal EF, which by its definition will pass through the parallel lines. Therefore, it is natural that we are going to have co-interior angles being formed. The co-interior angles, alpha and beta, are two angles within the parallel lines AB and CD. This is why we refer to them as interior angles. We also refer to them as consecutive or co-interior angles. This is because they are two angles which pair up or come one after the other in order to form the co-interior angle pair. If we look at diagram 2, the angles gamma and delta are also co-interior angles. Firstly, you should notice that both of these angles are on one side of the transversal, and that is the left side. These angles are bound, if you like, in between the two parallel lines, and these parallel lines are AB and CD. If we look at the angles alpha and beta, which are a co-interior angle pair, and the angles gamma and delta, which are another co-interior pair, and we look at these on the same diagram, we can see the two pairs of co-interior angles that are formed when a transversal passes through two parallel lines. What is special about co-interior angles? Co-interior angles are supplementary. Supplementary angles are pairs of angles that, when added, generate a sum of 180 degrees. For example, 50 degrees and 130 degrees are called supplementary angles. This is because when we add these two angles together, we get a 180 degree angle. If we look at the angles 10 degrees, 70 degrees, and 110 degrees, these angles are not really supplementary angles. And the reason for this is, if we add these angles together, we do indeed get 180 degrees. However, we have three angles rather than a pair of angles or two angles. And so, the definition of supplementary angles is not really met. Let's look at the following diagram. Now, looking at this diagram, we need to take note of a few things. Firstly, the line XY is parallel to the line WZ. Also, we have a line AB which cuts through the lines XY and WZ. So, AB is our transversal. Therefore, we know that we are going to have co-interior angles being formed. Rho and tuph are co-interior angles, and lambda and sigma are co-interior angles. Co-interior angles are supplementary. In other words, when we add them together, they must give us a sum of 180 degrees. By referring to the diagram, we therefore see that rho plus tuph equals 180 degrees, and lambda plus sigma is equal to 180 degrees. The last thing that we need to look at is how do we identify co-interior angles? Co-interior angles can be associated with a U shape or a C shape that is orientated in different positions. So let's look at a few examples to clarify this. If we look at diagram 1, the angles alpha and beta are co-interior angles. These form somewhat of a backward C shape. If we look at diagram 2, alpha and beta are again co-interior angles. The transversal and the two parallel lines sort of form a U shape in which we have the two co-interior angles. Again, if we look at diagram 3, we can see that the angles alpha and beta, which are co-interior angles, are associated with a backward C shape that has been slightly tilted or reorientated. And finally, if we look at diagram 4, alpha and beta are again co-interior angles. This time they are associated with a C shape that has been tilted ever so slightly.